Okay, let me know. Oh, I saw the live come up, so I think we're ready.
There you go. Yeah.
All right, great. First of all, thanks everyone for joining our first Rundeck office hours session. My name's Dawn Van Hogarden, and I'm VP of Marketing here at Rundeck, and we're excited to have you here and to start this new feature of Rundeck and get closer to our customers. Today on the call, we have myself and then also two of the co-founders of Rundeck, Alex Honor and Damon Edwards. Damon is our Chief Product Officer and Alex is our CTO. And some of you may have interacted with one or both of them in the past. Today, the focus is on the new Rundeck Pro Cluster features. We're really excited about all the work that we've done with this, and I think for those of you in enterprise environments, it will be a great aid and help you make your life a little easier when using Rundeck and getting some of your work done. So just a little housekeeping. I think most of you are doing it anyway, but just if you could mute yourselves when you're not speaking, just so everybody can hear well. And then also, if you have questions along the way, we really do want this to be interactive. So please go ahead and you can chat your question or unmute yourself and ask a question, while we're in the area that you're curious about, just so you don't lose the thought. Joining you from today. If you want to share where you're working, where you're joining us from, that would be great. Just so we can get an idea. It's always fun to see where our customers and users are hanging out. And then after that, we'll get started. So Aziz, you want to kick it off?
Yeah, for sure. So, hey everyone, my name's Aziz. I'm an account manager with Rundeck, and I'm based in the Bay Area.
Hi, my name is Killian. I'm a senior DevOps engineer with Proofpoint, based out of Belfast, Ireland.
Nice. Actually been there. That's a cool town.
Thank you. I think so.
And then I think we have two folks from Orlando as well.
Hi, myself Manideep. I'm a Linux system engineer in Aspect Software.
Great. Thank you. And you're joined by your colleague Chris as well, I think. So with that, we may have some other folks. Some other folks join us, but I'll turn it over to Alex now so he can get started.
Hey, everybody. Hey, firstly, I was curious if anybody had tried to set up a cluster or maybe say a little bit about high availability or failover or thoughts about how you might want to scale. Or are you just curious to see what we're working on as far as the cluster goes? Can everybody hear me all right?
Yeah, I don't know if you saw the chat, Alex, but Chris is saying he hasn't tried to do high availability with Rundeck, but he has lots of other apps.
Okay.
That he does run in HA.
Okay, cool. Well, yeah, let me just kind of first explain a little bit about what our goals are with Cluster. We have people trying to either set up kind of active standby pairs so that, if one of the Rundeck servers goes down, they can automatically keep the service going. Other people want to scale in different ways. They might want to add more capacity by having more instances. And they may also want to partition where the workload actually runs. So instead of just having, you know, 1 or 2 Rundeck servers that take all the workload for all of your projects, you can start to dedicate some capacity for some of the workload. And that might come up not just for the reason of having a lot of workload, but there could be resources that some of the Rundeck servers need access to, but maybe not all of the jobs and all the work in other projects might need. So that could be network related. Maybe you have some remote nodes that are in a data center, and you want to make sure that all of the outbound traffic goes through a particular set of members. And you might have another environment or data center where you want to do something like that also. So the Rundeck cluster can be used to kind of manage traffic, you know, kind of both user traffic and also, you know, kind of workload, but finally maybe even remote execution. Does that make sense? Okay, so let me just talk a little bit more about, I'm going to share my screen. I kind of think of the Rundeck cluster a little bit like Lego bricks. And I'm going to just walk through a few different models of how you can set up a Rundeck cluster. And then I'm going to show you a demo of the Rundeck cluster itself. So this kind of just goes through some of those ideas I just mentioned, ways you can model a cluster. So the first thing to know is that architecturally, that's where Rundeck is going. Rundeck is going to be a clustered software. You might have one member of the cluster, which might be how many of you are hosting Rundeck now. But you know, you can add new instances to your cluster and start to kind of accomplish some of these different models that I'm talking about. So that's an important thing for us, is that we're kind of designing, you know, this year going forward, that it's always clusterable. I mentioned, you know, the active passive configuration. I think that's what most people are looking for when they're thinking about disaster recovery. You know, there's a really key concept in Rundeck. Firstly, that there isn't a master in the cluster, but there is something called a schedule owner. So if you run jobs that are just on-demand jobs, like you've got some self-service tasks, maybe restart services or do something diagnostically, we call those on-demand or ad hoc job runs. But you know, you might have a bunch of scheduled jobs, maybe things that you took in from cron or some kind of job scheduler. And there is a member that owns that schedule. What that means is it is tracking the schedule, and when the next occurrence of the job should run, it invokes the job. So we call it a schedule owner. And part of the cluster management is to automate that's what we call the schedule takeover. So if you ever look through the Rundeck API, you'll notice that there's one of the endpoints that is about this schedule takeover. So you can always use the API to manipulate that, but part of the cluster management is to automate that for you, so you don't have to worry about, you know, how do you tool a schedule ownership change. The other kind of key thing about this drawing is that there's a load balancer in front. This is load balancing user traffic. So, you know, you could, for example, have 2 members in your cluster and explicitly set one of the members in passive mode. So you might have tried this also. You can go to the system page and change what we call the execution mode from active to passive. When it goes into passive, you can't run any new jobs. And you'll notice that if you try to press the play button, it's kind of grayed out, and it just means that you're in passive mode and it's not intended to execute something. So if you wanted to explicitly set something kind of in a maintenance mode, that's how you do it in Rundeck, is to put it in passive. So just taking that idea a little bit further, active is basically just like what we saw before, but both members are in that active execution mode. And with that web load balancer in front, either one could get traffic. So, key point here is that depending on your load balancer, there's different health checks that you could think about. Obviously, the easy one is it responding to HTTP, but there are API endpoints in Rundeck that you could expose that give you deeper info about the health or how busy your members are. So you can, kind of instrument this so that when a new user comes in, you may pick the least loaded one. So that's something for you to consider. The two endpoints there would be, for example, the system info page or the metrics page, which returns JSON. So different ways you could script and choose which of those metrics from either of those endpoints to use in that health check, but that's the starting point. Now, this is something kind of new that is possible using our new cluster software. We call them front ends and back ends. We have a number of users. Definitely when the organizational scale is more than just a couple dozen people, where you really want to isolate the traffic that the end users are putting on your cluster. So a lot of times you want to open up access to Rundeck just so that people can look at activity. Can I see the job run history? Can I see what's running? Can I see what's scheduled? And you don't want any of that to impact the workload that's going on, or more likely vice versa. You don't want to impact your user experience because you've got a lot of executions running. Some people have hundreds of simultaneous executions running. And so one thing you can do with the cluster now is designate members to kind of play these different roles. So what that means is that you could have a load balancer or just have a single Rundeck instance that is part of that public URL that all of the Rundeck users are going to connect and access to. So they do all their normal Rundeck kind of UI stuff in here. But when it comes down to running a job, it goes through a dispatcher inside the cluster, and it goes through what we call this internal cluster messaging queue. This is really just part of the cluster manager software I'll talk about later. But just picture it like this. A person wants to run a job, it gets queued, and in the cluster management software, there's a dispatcher that says, okay, which one of these other members is going to execute the job? So we call this remote job execution internally, but that's really how you designate that. So now we can browse here, no matter what kind of workload's happening in the back end, we won't get affected as far as kind of load. So this is pretty interesting. Now, this takes that idea and just scales it way up. So, if you've got redundancy needs, you want to make sure everybody can access the Rundeck farm, and you want to have multiple backends, and maybe more importantly, you want to move to a model where you can auto scale Rundeck. This new architecture was really kind of designed for that. So you can set up your cloudy infrastructure to spin up new members of the cluster. When a new member of the cluster starts, all that it really is doing is connecting to the same relational database and log storage. And as soon as it joins and the service starts up, it starts generating heartbeats. So every member of a cluster is always generating a heartbeat. A heartbeat is just a periodic push of data that contains a lot of the same information that the system info page does. So it's going to be like utilization, about CPU, memory, how many current jobs are running, how many scheduled jobs it owns, and so on. So there's a bunch of data like that. But the important part here is that that's what tells the cluster manager who is alive and metrics about how busy they are. So as soon as a member is added, whether it be kind of through an auto scale or you just, at a point in time install another one and connect it to the same backends, it'll just start up telling everybody else, here I am, and the cluster management software can start to decide what to do about that. So that's front ends and back ends. So now that you understand front ends and back ends, the last logical kind of point here is that you might want to start partitioning where the workload goes. So I might have project A and project B, and maybe I've got lines of business that just told me there's no way I want any workload from another project to impact my resources. I want to make sure that they're completely my resources. I don't want to share capacity with anybody else. I don't want to even worry that maybe they could get some privileged access that affects my security model, anything like that. So if you have like these kind of strict rules, or you really just want to dedicate capacity, that's another thing you can do with the cluster. And we do that through tagging. I'm going to show you that in just a moment when I bring into the demo, but you can tag any of these members, front ends and back ends, with labels. They're very much like a Rundeck tag that you're used to. But this logically defines the members into roles that they can play. And one of those roles can be, I'm for this particular project. So when you go to configure your cluster, you can start to map. Anything that goes for this project is going to be running on members tagged, project A. So you can even load balance across those as well. So yeah, this is kind of like the logical end into this kind of what I call the Lego brick style of cluster architecture. So any questions on that before I jump into the demo?
Hey, just one question on the active passive checks. How might a load balancer typically detect that?
There's in that system info, whether it be JSON or XML, the response that returned from that, there's something called execution mode, and you check that. In fact, there's two ways to get it. One is execution mode. It will either equal active or passive, but there's also Booleans that you can check. It just says, is active, true or false. So there's a couple ways you can find that out.
Okay, okay.
Yeah. So let me bring up the Rundeck UI now. And
Alex?
Yes.
Sorry, there is a question.
Okay.
I'll read it to you. It says, we have a PCI and production network with separate Rundeck servers and individual Rundeck servers set up regionally. The big issue has been keeping projects, OBS, I'm not sure what that is, in sync and node lists, and utilizing different SSH configurations while reusing jobs projects without maintaining scripts to specify SSH details in the node list itself. Namely, PBIS, likewise, Active Directory, I think, connectivity with different domain prefixes. Does HA introduce a solution for syncing jobs between separate Rundeck servers jobs?
Yes, that's a good question, Chris. There's a couple of plugins that come with Cluster for replication. And one plugin is for replicating jobs, and the other plugin is for replicating execution history. So, if you've got really these kind of pretty much physically separated Rundeck environments, you can configure them so they kind of connect to each other over HTTP to let the other one know, hey, I've got a new job change. So if I create a job or I change a job, delete a job, it will, tell the other Rundeck server to do that likewise. And if you execute a job, you can configure to tell another Rundeck server, here is the execution object. So what it looks like on the other Rundeck server that's receiving it is, it's almost like it ran it, but it's just getting a blob of data. It's getting the execution metadata about it and the output. So the plugins try to be a little bit smart about this by queuing it up. So if you've got a really busy Rundeck server, it might not do that as it happens. It might kind of queue them up into maybe 10 or 20 and then batch load them over there. So that's a tuning parameter, how often you want it to sync. But you know, the idea is it prevents you having to write those kind of scripts where it's trying to catch that kind of at a lower level and push it. So that's a good question.
Does that answer it for you, Chris?
Okay, cool. Yeah, and Chris, we could follow up over email if you want to get deeper into that scenario. That was a general answer, but yeah, there's some other things that might go along with that, specifically like the node list. Okay, so here I have my Rundeck server. I've got a couple of projects. I'm in a cluster, because I can see that down here. Couple little tidbits to know about. This is the Rundeck server my load balancer directed me to. So I'm in a pretty realistic demo here. I've got a web load balancer, it's HA proxy. I have a couple of my Rundeck members in here. You can tell it's all hosted in Docker. Any case, I happen to land on cluster 1. This little funny thing here is a way of knowing what the UUID is for the cluster member. So every member in a cluster has a UUID. In fact, nowadays when you install Rundeck, you automatically get a UUID.
Hey, Alex, can you expand your browser, maybe bump up your font size?
Yeah.
It's a little hard to see.
Sure. Thanks for letting me know that. Okay, so let me make this a little bigger. All right, yeah. It's not important that you really know all this, but if you're a Rundeck admin, it probably is, because you might want to know where is the user landing. So just wanted to point that out. Let's go over to the cluster manager. So you can see here we've got this little UI now to tell us about what's in our cluster. You can see there's cluster 1. That's the one that we're on. And there's this word called front. So that's one of those server tags I talked about. I could have more than one, but in this kind of basic demo, I've just added one. Little information about the OS. Here's that execution mode, active. You can see they're all in active mode. I could press this button and change it to passive right now. I'm not going to do that, but I'll do that in a little bit. So if you were wanting to take something down from maintenance, this is what you could do. You could just come right here and change it to passive, and no new executions will go there. And more importantly, if you're using this cluster dispatching, no new executions will come in through that either. Gives you a little summary about schedules. You know, I've got 7 scheduled jobs. 6 of them are actually enabled to run. This one's got 1 scheduled job. So this is good to know what members are owning schedules. Here we see how many jobs are running on each member. I haven't run anything behind the scenes right now, so everything's kind of idle, but you know, you might want to press this button here and it will rank the you know, your most busy member. CPU and memory, pretty self-explanatory. Like I say, all this data is really coming from that system info. So let me just come over here and remind everybody what that looks like if you just went straight to that for a particular instance. We've got this thing called a system report. This is the kind of the HTML version of an API called system info. And you can see it's all pretty much everything I was just showing you on the other page. This is for just cluster 1 though. So what the cluster manager does is it's convenience as well, because it's essentially getting that same data for each member, so it consolidates it. This is a key point here, uptime. That's how long the member has been sending in heartbeats. So I booted up this whole cluster, and all the members basically came up around the same moment. You know, you might have new members coming in to replace old members, and there's going to be different uptime. Uptime really just means how long it's been sending in heartbeats, and most likely been in this pool doing work. So now what happens if a member goes down or something, I don't know, something's wrong, and those heartbeats aren't being generated? Well, the cluster manager will start to highlight this. First of all, if it's not meeting a liveness threshold, that dispatching code is not going to send any requests to it. It's just going to assume it's basically out of reach. But then this will start to turn red, and then it'll tell you how long it's been down, up to a threshold where it will just delete it from this list. All those parameters and thresholds you tune. Obviously, we have some defaults there, but just good to know you really control how long it takes before something's designated kind of unhealthy, or should it just drop out. Let me move over here. So if you're scheduling jobs, this page is pretty handy. Firstly, you can see I've got different jobs, and they're in different projects, and I might want to start moving things around. So maybe I want to move all of the job schedule ownerships to a different member of the cluster. Maybe I'm going to put them all over here. Let's put them all over here. This is one of those functions that is possible with the API that, you know, people automate, but it's kind of hard, to be honest, because you have to just collect a lot of data before you can get through all the API calls to do this. It's scriptable, but this is basically just making it point and click. So I just went and did that. I moved them over, and the other nice thing about this page is it's kind of a different way of knowing what's coming up. So if I click on the schedule, I can say, well, the next job to run is this rebalance job, and then one after that, and so on down the line. So this is kind of handy, just even if you're not changing the schedule ownership, it's kind of handy to just have a way of knowing what's coming up next. Or maybe I just want to know what's going on, you know, with a particular cluster member. Let's see, flip it again. So cluster 2 only has one job. So different ways to kind of slice and dice what's going on in your cluster as far as scheduled jobs go. So I'm just kind of curious, putting the question out there, if any of you have to deal with this kind of job schedule management, but yeah, just feel free to throw in a question. Okay, so let's go actually run some jobs. Now there's a couple of features under the covers that I'll just talk to it first, and then I'll run the job, and we'll talk a little bit more about it. But when you run a job in a cluster, Rundeck is generating what I call execution metadata, and that basically means a snapshot of the job definition at the time it ran, what nodes it's going to target, what the user login was, what options were given, and so on. And so when Rundeck begins an execution, it starts off with that. But as the execution proceeds, there are a bunch of state changes. And what that really means is that you're moving from, let's say, step 1, begin, to step 1 running, to step 2 complete, step 1 complete. And you do that through all the steps, and likewise through all the nodes. So when Rundeck executes, it's really generating that whole execution model. And then as the job proceeds, it's just kind of changing, you know, where I am in that model. So that's all together what I call the execution metadata. Also, the job is generating output, and Rundeck is using that execution model to know how to collate all of the output into those various steps and nodes and so on. So before we had the cluster manager, if you were to send a job to, say, cluster 1, and your load balancer directed you to cluster 2, the UI in cluster 2 would say, well, this job is running, but I'm waiting for it to complete on cluster 1 before I can show you the state and the log output. So you basically had to wait for the job to complete before you could get at any of that output. So a bit inconvenient. In the new cluster manager, we support something called partial output, and or partial log storage, I should say. So I'm running this job here. This job happens to be on Anvil's. We've set up the cluster policy so that Anvil's jobs can run on any of the nodes in the cluster. So I don't know, for luck or not, it happened to hit the same one. And let me just run that again, because I just wanted to kind of make the point as it runs, especially when it's on itself, as we like to say, we can look at the log output, right? It's just basically synchronous. I can monitor it this way, and see the cool little SVG chart and all this kind of stuff as it happens. But let's go over to this project here, and let's run a job there. Let's run this job here first. So we're still on cluster 1, and I'll run it here. Aha. So if you notice, we're not on cluster 1. We're on this one called headphones 24, which we'll find out where that is in a minute here. And you can see here it's waiting for summary report detail to become available. So, oops, let me run that again. And you can see it's waiting to pull data from the other node, but now it's getting it. So this job is a little bit too quick to run. Let me run another job here. Well, the first point I guess I should have emphasized was that you noticed it didn't run on cluster 1, it was running on that other member. So that's the execution policy in action there. So in essence, I just showed you the front end and back end model of execution. So this job takes a lot longer. It's probably a better example. This job here, you can see has 4 steps. It's going to run in this kind of fork and join order, and showing off a cool new feature here called rule set to let you manipulate the order of steps any way you like. But I happen to know that these steps take longer, so let's run this job again here, and so we're on cluster 1. It's again executing on that same member that it ran last time, which, just to kind of remind ourselves, let's go back here really quick to the cluster manager. That job will take a while to run, so it's running here. After we look at the job run, I'm going to walk through the configuration and explain how we set this up, but it's on cluster 3. Okay, so now you can see it's getting partial updates. It's not showing us that, waiting for execution, blah, blah, blah. I can tune how the partial updates work. In fact, on this demo, I'm still kind of messing around with that. But the idea here is now that we can start to ask the other Rundeck server for whatever log output has already accumulated, give that to me. So the cluster member that's executing the job, in this case, it's this cluster member 3, on a periodic basis that you tune, it's going to checkpoint output. And I think I kind of got a little bit too slow here, but it's a balance, right? You don't want it just to keep spending all its time checkpointing, but you want to checkpoint it enough that you're getting good user experience for your end user. So So what's happening on cluster 3 is this job's running. It's periodically updating the log storage with all this state change and log output, and enables the UI on the member we're on now, cluster 1, to do, basically render as it goes. So, we can even start to watch progress like this again. And the whole point here is so that you've got a simultaneous user experience that's the same, whether you're on the one that's actually just sending in the request to run the job, or or any other ones in the cluster, basically. So hopefully this is making sense. Any questions about that before I kind of step into the configuration?
Is there any way to adjust like the log streaming frequency in that scenario? Like
Yes.
where you can get more instant feedback?
Yes, there is. In fact, that's my next stop, is to actually show you the configuration to help you tune that. And yeah, I kind of forgot to say, this is a kind of a very miniaturized Docker based demo. It's realistic in that it has 3 Rundeck instances, so that's 3 containers for that. 1 container for the HA proxy, 1 container for the database, and 1 container for an object store for the log store. So there's actually, what is that? 5 containers running on my laptop. So I'm kind of tuning it to the capacity of my hardware also. But yeah, let's move over to the configuration now. Here we go. So it's not pretty because it's in my actual kind of personal demo setup, but it's good enough for me to walk through all of this stuff. So I'm sure you're familiar with 2 config files, one called the framework properties and the other called Rundeck config properties. So let's first begin with the framework properties. 2 important settings. One is the UUID. So this is probably already set for you when you installed your Rundeck. If it's installed through everything except the WAR file, I believe this is generated as part of the install. So you don't really have to worry about this. But in any case, UUID is important because that's what this thing represents, the unique identifier. If we didn't have a unique identifier, the cluster manager wouldn't know who is who. If they all kind of said they were the same UUID, it would create all kinds of conflicts. So that's a caveat, right? You want to make sure they really are unique. So the other thing are those tags I mentioned. Those are the things that you label your members with to play the roles you want to play. And what just happened there? Okay. Okay, so that's the only new thing you have to do, is decide what role that member is going to play. From there on, you want to set up the cluster manager stuff. So let's just kind of start here. Heartbeats. So a heartbeat basically is what I mentioned earlier. I think I'm loading a jar file, which hopefully is going to kill my Sublime text, but you can see how often you want to generate a heartbeat. I set it to 10. Actually, 10 is probably way too often. 30 seconds is probably more reasonable. And how long should you wait before you send your first heartbeat? Now that could be important because when you're spinning up your Rundeck member, maybe you've got other kind of setup processes that you want to do. Maybe you want to bootstrap it somehow. Maybe you want to call the Rundeck command line to do something, or who knows what. You can control how long it should wait before it sends the first heartbeat here. So, you might need to give yourself a little startup time before you want to advertise yourself. All right, now I talked about this this remote execution ability. That's front ends to back ends and all that kind of good stuff. Each member is looking in the queue to see should it do something with respect to these kinds of remote executions. So this is kind of how often it's going to go find out anything as far as should I execute something, should I abort something. 5 seconds, probably okay. You know, I think that might be the default even. I think this one's kind of self-explanatory. How long should you wait before you consider that member inactive? 150 seconds is probably okay. And then, you know, when is it going to be eliminated from that list? So when is it going to just be dropped out of this list? Up until that point, this is going red and it's going negative and telling you, oh, it's been down for this long. Maybe it's going to come back. I don't know. But once it reaches 300 seconds, you know, 5 minutes, it's just going to drop out of the list. Now, if that member somehow came back to life, it's basically kind of sort of reincarnated, I guess you could say. It's going to start all over. Its uptime is going to start from, you know, from 0 and then start building uptime again. So it sort of lives to see another day. You can set up a default remote execution policy. I commented this out earlier. It was a different demo I was playing around with. Probably a good idea to set this as a default. There is a natural default, but it's probably better for you to decide for yourself, because you might want to say where the execution should generally run. One thing I didn't talk too much about yet is the policy. So let's say you've got, coming back over here, a couple of members. This one's called worker, and maybe we call this one worker also. The policy decides, well, if I've got a remote execution and you're telling me to send it to worker, which worker do I send it to? So that's what we mean by policy. So in this one, it says random, which, you know, just means we'll randomly pick from that set of 2. You know, you don't care, just pick one. There's some other policies. Round robin is going to cycle through them in order. Preset is going to let you define your own order. And in our next version, we're going to have various load balancer ones that let you pick metrics about what you consider the least loaded. So yeah, we'll be looking for your feedback on that, but that's an example of policy. These policies are basically algorithms that we can add as a type of a plugin, not like your typical plugin, but it's pluggable. So we can you know, work on different ideas and algorithms for this kind of load balancing over time, and you can just choose a new policy. This policy here is not the default policy, but it's similar, but it's a named policy we call a profile. So I've just called this profile the e-options profile. I could name a profile maybe by line of business or by environment. It doesn't matter what I call it. It's just a name. But then I can apply that profile to one or more projects. So for the sake of a simple example, I wanted to make sure all of my executions for this project called e-options are going to round robin over any member tagged e-options. So I only have one member tagged e-options right now, but that's an example of a round robin policy. So if I want to do it per project or by some set of projects, this is how I do that in setting up the policy. Okay, so talk a little bit more about the setup. And that's auto takeover. So I mentioned, you know, let's come back here to the jobs page. And let's say, you know, I've got all my e-options jobs here on cluster 3. So if cluster 3 went down, you can see I've got plenty of these scheduled jobs. I want to make sure that another member of the cluster is going to take over the schedule. And while I could do that here, I could manually do that here. If it was a planned maintenance, maybe that's what I would do. But you know, in an HA environment, I won't be around probably when the thing goes down. So different policies for doing that, and this is basically kind of, I think this is essentially the most simplistic way to define that. But I could again decide which server members tagged a certain way should take over, or maybe I'm just going to say, no, I'm going to tell you exactly which ones should take over. So you could map it by the server UUID or by tags. Key thing here is that you want to enable it. You want to enable that you want this automatic behavior. Some people would rather just always make it manual, but so we make that flag you have to set. And then finally, how long should you wait before you do the takeover? So that's 60 seconds. That's probably the default. But you can change how long you should wait before one is down before you just start taking over its schedule. Obvious some caveats there. The member that's taking over should have the same basic setup as the member that died. I don't know if there's some local steps or other kinds of operating system things that the job assumes are there. Want to make sure about that. Okay. And then lastly, which was that point about these partial log stores. We're talking about that. How often do you check? So these are all tuning parameters. In fact, I don't think I restarted since I changed this one to 2 seconds, but you can see this is how often you should checkpoint into the log store. You might want to set a minimum time for the first one, and then different sizes of the checkpoint, and so on. In fact, I know there's a couple more settings that I could set that aren't in this example, but we're working through kind of a good balance of these settings for the default. So hopefully for most people, what we come up with out of the box will be pretty good, but depending on your network latency and the kind of log store you're using, you might want to fiddle around with these. So it kind of gives you a good user experience. Okay, so that was kind of deep into the guts of the configuration. Maybe I'll stop again and ask to see if there's any questions.
Hey, Alex, this is Dawn. No question, but I just want to give you a little time alert that we have about 8 minutes left. So,
okay, yeah, thanks.
Just if there are key points you want to hit, thanks.
Yeah.
Quick question about, you had mentioned that it can do round robin or random. So like it doesn't currently look at like how many jobs are running on one server and then say I'm going to give the next job to this server because it has 0 and this one's running 2. It just like randomly picks it right now.
Yeah, that's right. And the next version will have what we call the load balancer policy set that does exactly that. Yeah, you depending on which load balancer policy you pick, it might be by number of executing jobs or number of scheduled jobs or CPU threshold or exactly. Yeah, so expect to see those next. Yeah, I think that was kind of my demo I had in mind. A couple of things I just wanted to leave with you, and that was the log store, right? The log store is an important back end to the cluster, and there's different ways you can set that up. This demo is actually using a S3 compatible object store. We have a lot of users that have that kind of capability, whether because it's an Amazon or they have a third-party solution running in-house. I'm actually running something called MinIO, M-I-N-I-O. It's pretty cool. It's an open source object store. I'm always amazed when API compatibility is real, because we can use the AWS command lines and AWS S3 client libraries against it, and it seems like it doesn't know any better. So that's pretty cool. It's clusterable itself, and it can shard, and it does all these fancy things. But if you were looking for an object store, take a look at that one. We're using it now. But it's a plug-in point, and I think that's really kind of a key thing for everybody to know. This is a plug-in point. This is a UI to the log store also. So you can see in my demo, even though it hasn't been up very long, I've already executed 246 times, and it's put that many execution objects in the log store. This is something you just get as part of cluster. So you might want to know how much activity is going into the log store, and it can even do certain things for reliability. Let's say, I don't know, maybe the object store got busy, or maybe there was some network latency, or even possibly a flap that prevented a put to the log store. The log store plugin will actually queue it and just keep trying. You can see it'll attempt it up to a certain amount of times and start batch loading them. So it's kind of it's a cool feature. I don't often look at this, but it comes in handy when you start thinking about the log store. And really where I was going with this, besides just kind of making you aware of it, is we're interested in know what other backends would be good for you as far as log store. You could always just mount a file system, and then basically it's like sharing the same volume. But that's not possible for many environments for different reasons, especially when it's across like geos or different availability zones or regions or subnets and so on. So in that case, you kind of need something that's more network oriented. So yeah, if there's any thoughts on that, now we can talk about them, but something maybe food for thought, and let us know in the future.
Okay. Thanks, Alex. I was just going to say before we run out of time, if there are any non-cluster questions that you have, just general Rundeck questions, we're happy to answer those as well. You might as well take advantage while you have the experts here.
Is there any sort of like version control plugin for jobs and like XML and YAML data that where, if you update a job or something like that, it would be updated in a repo or vice versa? Or is that just something that, you just have to use the CLI to export and then manually, or like through scripts of your own upload? Is there any way to version control like everything that's in Rundeck through the Rundeck interface in the enterprise version?
Whether it be the enterprise version or the core version, take a look at this under your project control. There's something called setup SCM. It's really out of the box supporting Git. So you can see we have export and import. What that means is that when you create a job in Rundeck, it'll add and commit it and push it to your repo. And if you make a change in the repo, Rundeck will notice that and pull and import it. So this is really probably where you should start. You can basically just configure it to whatever the repo name and the branches that you want to use. The repo can contain more than just the job definitions. So if there's other files that you want to kind of move back and forth through that process, they can just be in the repo, and you can address them through the base directory, basically. This is kind of the workspace to the repo. So start with looking at that and follow up with us if you need any help configuring it.
Cool. Yeah, was that introduced recently or just something I missed over the years?
It's easy to miss. Yeah. This is the newer kind of navigation, and the older navigation, it's there too, but yeah, you might have just missed it. Yeah.
Awesome. Perfect. Thanks.
Okay, well, we're running up on the time. So if there are any questions, please ask them now. Otherwise, you can also, if you would like, email me, Dawn at Rundeck, or any of us. We're all first name at Rundeck, Damon at Rundeck, or Alex at Rundeck, with questions after the call. Or if you have suggestions for next month's office hours, a topic that you'd like us to dive into, we'd appreciate it. And yeah, just like to thank you for attending. This was our first effort at this, and I think it was a good session, and thanks to Alex for doing such a great demo of Cluster. And hopefully we'll see you at the next one. Damon, do you have anything? Or Alex, close? Okay, we're right on time then. So thanks again, and please, like I said, follow up with us, and then the demo will be on YouTube. The session will be on YouTube, so you can, if there were parts of the demo you want to review, you can see that there. Or we're happy to schedule a live meeting with you as well.
Sounds good. Thanks, guys.